we've talked architecture. We're moving more into, okay, how do I actually set up the guardrails around what folks can do, how they're working with the workspace, and how can I best enable them. The admin console is where you're going to have the ability to turn on all of the features that let you do that. That includes managing users, creating and managing groups, putting users into those groups, adding IAM roles and mapping them, enabling the access controls, like I said, and then setting up single sign-on. Now let's go to the admin console. So if you're an admin, you're going to go here in the top right, and when you click on this dropdown, you'll see admin console. And that's going to populate just like this. So as you can see here, this is a Sharded user demonstration, so everyone's an admin. Definitely best practice, don't do that. You'll want to restrict admin usage as much as possible. And then you can also see that by being an admin, you by default have cluster creation privileges, but that's going to be another thing that you want to take a look at and restrict as well. So ultimately, in terms of generating costs, cluster creation is what will allow users to generate costs. Is if they can spin up clusters and control how big those are and who has access to them. That's going to be one method of kind of controlling who is generating costs for you. So I tab over one more, we'll get into the groups, and that's one step above, one step of abstraction above the users, is you can put them into groups and manage them that way. So you can see we have one for data scientists, for example, that has a couple of group people in it. So you can specify entitlements. So in this case, it just has cluster creation, specify the IAM roles that they have access to, and then creating kind of parent and subgroups as well. Okay, jumping into IAM roles. So these are the IAM roles that are going to be associated with a cluster, and you can see who has access to those. Let me go back to the cluster screen to give you an example of what I mean by that. So I'm going to go into this cluster. I'm just going to hit edit really quick. And down here in the advanced options, I can go into IAM role and I'll see the list of IAM role policies that I have access to. Now, as an admin, I have access to all of them, so I see all of them here. But you can specify which users can access which IAM roles, and that'll limit what, when they attach to this cluster, it'll limit what kind of access they have in terms of buckets and things that they can get into. So there's kind of two layers here. So one is, of course, the IAM role, and that's associated with the cluster. So as you can see, I'm editing here in the cluster. And then you can also control which users can actually use a cluster itself as well. And I'll show you how to enable that in just a second. So jumping back here to IAM role, so that's right here. Workspace storage. So purge workspace storage. So what does that mean? Well, within each person's directory, everyone has a trash, a recycling bin, and so they can go in and basically go in and just move something to trash. And so that's in here now, and it's going to sit here. But if you wanted to go in and get rid of all of those and clear all of the trash in the workspace, you can do that from here by just purging it. By default, it'll be 30 days before it auto erases the trash. Revision history. So that's purging revision history for notebooks. So when you make changes into a notebook, this is kind of, if you've used Google Docs like that, will be very similar, but you'll have a revision history of all of the changes that have been made recently to that notebook, and I can go back and take a look at it and make a restore to that version if I needed to. But if you ever needed to go in and purge that history, well, this would be where you do it from, is in the admin console, going into workspace storage, and then purging based on the time frame that you specify. And then cluster logs. So purging cluster logs, that one's kind of self-explanatory. What I will point out is this is going to delete cluster logs that you're able to view here in the UI. But what you can do, I'm going to jump back in here. I'm going to hit edit one more time, go into advanced options, and go over to logging. So one capability that you have is basically to specify a location to save cluster logs out to. This is recommended as a best practice, especially for a production cluster, so that you have an easier time going in and debugging it. When you have one of those running up and running, it'll just go out and save out all the cluster logs to that specific location. So do recommend this, but if you don't specify this, so right now there's nothing specified, I can still go in and take a look at all of the driver logs and in the Spark UI and dive into what's going on with the cluster. But if I were to purge everything, then that would not be available to me anymore. Okay, access controls. So when you initially create this workspace, before you have, hopefully before you have any users signed up and accessing it, all of these will be disabled, so you can go in and pick and choose what you want to enable. I'm going to briefly talk about all of these, and then I'll show you also what all of the options that you have available to you in terms of what you can select in just a second. But starting with workspace access control. So this is access control around all of the workspace level items. So that's things like the folders and the notebooks. So things over here, as you can see, I have this permissions option here. And I can specify which user, which group can do what with this specific notebook that I have here. You can also apply those at a folder level. If you do that at a folder level, it will pass down to anything that's contained within that folder with the same permissions. Cluster, pools, and jobs access control. So this is access control around what folks can create create clusters, can attach to clusters, can edit those clusters and manage them, as well as who can create pools and who can create and access jobs. Now, clusters we went into, jobs, well, those are just jobs that you can schedule to run automatically within Databricks. Pools, the idea of pools is basically that you have groups of instances that you can hold in kind of this, you can just basically reserve and hold for a period of time. The purpose of that is basically twofold. One is it will significantly decrease the amount of startup time it takes for a cluster to get going. So normally a cluster startup time could be anywhere from 1 to 3 minutes. A lot of that is basically the acquisition process of getting an instance from AWS. But if you have a pool of instances, then you can immediately draw from that pool, and that cluster startup time is significantly reduced. In addition to that, you can also use it as an auto-scaling buffer too, if you wanted to do it that way, so that clusters can scale up more quickly. I'm going to go into one of these really quickly. So you can specify the type of instances that are in that pool, how long you actually retain them. So in this case, if an instance sits idle for 60 minutes in this pool, it will then be released and unavailable. And then you can specify minimum and maximum numbers. So it'll keep at least 2 idle pools in here, and at most it'll keep 4. And you can kind of manipulate those and change them however you like. Table access control. So this is now when you are trying to do more fine-grained permissions on tables. Basically, doing access control at a table view in terms of what folks can edit and manipulate with the table, or any derived views with it. This should make more sense when I show you in just a second some of the capabilities there. Personal access tokens. So if you are using the web API or the REST API, this gives you an alternate way to authenticate with the REST API by using personal access tokens rather than using your login credentials. And then authenticate to external systems. So there's the ideas portal, and that's our feature request portal, and then the help center. So the ideas portal is where you're going to request features from us when you feel that there's a feature gap. You can view other folks' feature requests that are already existing and vote those up. And when I say other folks, I mean any of our other customers as well. It's kind of a central portal for everyone to do that. So you have more visibility into what is being requested and the ability to kind of cumulatively request key features as the group so that we know that those are important to you. And then the help center. So that's where you're going to be filing support requests and basically getting help with troubleshooting or talking to a Spark specialist. There is single sign-on. So probably will be very key if you haven't already set this up. This is where you'll do it. We have a couple of guides on individual IDPs that are very popular, Okta, OneLogin, things like that. But anything that is basically authenticates with SAML 2.0 should be compliant, and you should be able to get it to work. In addition to that, we also have a SCIM API that you can use to manage users with just an API interface rather than having to go in and do all of this manually by hand. Cool. And then some of the advanced options. So this screen may look slightly different for you. So I'm using an internal kind of demonstration workspace here. So as we do updates, those updates can change some of the options of what's available in terms of something that might be in preview or that we're betaing. So may not match 100%, but what we have here is, so I'll just talk through a couple of these that are more common. So there's the Databricks runtime for genomics. We have multiple flavors of the Databricks runtime that are tuned for different use cases. I'm going to jump over here, create a cluster, just to give you an idea of what I mean by that. So when you're creating a cluster, you'll actually specify the Databricks runtime that's going to be utilized within that cluster. Here you can see that we have quite a few options going back to 5.5. LTS means long-term support. So we'll support those for 2 years and then an extra year after we've alerted you that we're deprecating it. We have ML variants, which are tuned specifically for machine learning use cases. If you have folks that are trying to use GPU instances to, let's see if I can find them. So if they're trying to use GPU accelerated instances, the way that they're going to be able to use those, as you can see, they're grayed out for me, is by changing the runtime to be an ML runtime. And then, of course, there's the beta runtimes and things that are coming up new. So the 7.0 beta that we have right now is going to include the Spark 3.0 preview. As best practice, again, we recommend using the latest non-beta runtime when possible. So the next item on that advanced features list was enabling container services. When you go in and turn that on, you'll get this option here. Using your own Docker container. So if you have a workflow that relies very heavily on containers, and that's kind of the way that you operate, you may choose to enable this and basically work from your own containers. The way that this works is that you'll provide us URL for wherever that AMI lives. When the cluster is starting up, it will go in and basically acquire that image. There's some minimum requirements that we have. So it needs to include JVM, it needs to have Python. So there's some things that are specified on our website that you can read about in the documentation about exactly what is needed. Assuming those requirements are met, it will take your image and then overlay the Databricks runtime that you specify. So in this case, it'll take your image, overlay the 7.0 beta runtime, and then send that to the cluster to be used to actually run your workloads. All right. I'm going to jump back over here, admin console advanced. Notebook Git versioning. So that's what I showed you with the panel with the notebook version. So I'm going to just go back into that really quickly. So this is using the built-in versioning with Databricks. As you can see that I don't have Git linked to this, but I could if I wanted to and have this working with a Git repository. This is basically the option to disable that. Download button for notebook results. So I'm going to go back again to that Delta demo. If you run a command, it's going to populate with some results. It'll give you the option to download those results to your local machine. This is basically a way for you to disable that download button. So as you can see here, there's a download button right here. So this would download a CSV to my local machine. So compute types. So we talked a little bit about clusters, and I'm gonna hop back into the web app in just a second to kind of show you materially what this looks like in practice. We have two different kinds of compute when you're usually using Databricks. So there's all-purpose compute and jobs compute. When if you were part of the process of creating a contract with Databricks, you've probably heard of a DBU. But in case you haven't, it is the unit that we use in order to basically bill. It is compute over a period of time. Based on the type of instance that you select, those DBUs can be generated more quickly. So bigger instances will more rapidly generate DBUs. And in addition to that, the pricing for DBUs is different based on the type of workload that you're running. All-purpose compute is basically anything that is running on an already, or anything that is ran on an already existing cluster, that would be considered all-purpose compute. I'll show you exactly what that means. Maybe it might make a little bit more sense rather than talking through it. Jobs compute is run on ephemeral clusters. So this is something that was scheduled or submitted through the API. It's run on a cluster that spins up specifically for that job. And then when that job terminates, the cluster itself will also terminate. In general, jobs compute is used for jobs clusters where it's single user or a production job, good for isolation and debugging because all of the logs will be individualized to just whatever was running on that cluster. So easier time debugging that, and they're lower cost. All-purpose compute is really meant for ad hoc workloads where you have a cluster that's shared amongst a team. They are a bit more expensive, but on those clusters, if you're running them as high concurrency clusters, you'll get more isolation between users. But then as kind of a side effect of that, you don't get the ease of debugging because all of those logs for all the notebooks that everyone's running are going to be mixed in together. Again, in the cluster screen, I'm going to minimize these. So the cluster screen itself will actually visually show you which type of cluster you're looking at. So the jobs clusters for all job runs, those are jobs compute. And then all-purpose clusters, anything that is an already existing cluster. So if I go in and create a cluster using this button, it is actually creating an all-purpose cluster. What I would want to do is go into jobs. I have one created here. And you can see that this job is using an already running cluster. So I'm going to go in here, I'm going to edit it and choose new job cluster. And you can see that it warns me if I use an existing cluster that it's going to be considered all-purpose compute. So what I would actually want to happen is this, new job cluster, and then specify all of the information I want right here about how I want that job to be run. If you're working with the APIs, you'll see it'll be very similar. You're going to, in the body of the API request, either specify a cluster template where you're telling Databricks what kind of cluster you want to run with what kind of runtime and all of the details. You can try to specify an existing cluster, but again, those are going to generate those all-purpose compute DBUs. So as a matter of best practice, whenever you're running jobs that are production jobs or are repeatable, we recommend scheduling them or submitting them through API and using these ephemeral clusters so that you can take advantage of this lower cost jobs compute. The purpose for these the all-purpose clusters or the existing clusters is really when you have something that's shared amongst the team, when you're doing kind of ad hoc work, regular development work. And even in those situations, it might be a good idea, just as a matter of policy, to create separate clusters for individual teams or for an individual use case. What I mean by that is that you might have a shared cluster for the ML team, or a shared cluster for analysts, or maybe there's a shared cluster that's specifically dedicated to doing BI reporting or things like that. And the point of making that recommendation is that it will give you a little bit more visibility and flexibility into what is actually generating most of your DBUs. So when you go and take a look at your usage, that usage is actually isolated by cluster. There isn't, because you can have several users on a single cluster, it's not actually at the user level. But what you can see is at a cluster level, how many DBUs did this cluster generate?